Okay, so in this lecture, we're going to be reviewing how to do Table G problems. So Table G is the solubility curve table, and this table shows us how temperature and the amount of water, so we have temperature that affects how well something will, the amount that a solute can be dissolved in a solvent. Okay? The solute is listed right here as all these different chemicals, and it shows how their ability in terms of how much of the solvent can be dissolved in a certain amount of water. There are primarily two variables that affect this curve. There is how much water, okay, I'm sorry, I should say that is a factor. There's three variables. There's how much water, not two, how much solute particles, and in terms of mass, and what the temperature is. So these are the three factors. As I said in class, you have to make sure how much water you have. Okay, this chart is based on 100 grams of water, and you have to know that these numbers to the left are the amount of solute particles. These are the chemicals that we're talking about, their respective curves, how much is being added per 100 grams of water. So if you think that each solution is 100 grams of water at some temperature, which is listed on the x-axis, okay, it's the independent variable, all right. The dependent variable, of course, is the amount of solutes. These are the grams of the chemical, all right, and all of these chemicals, all these solutions that are being made and tested to make this graph is per 100 grams of water. So if you had, let's say, 5 solutions, okay, 5 beakers, and they all had 100 grams of water in them, okay, and let's say you have 10 degrees Celsius, 20 degrees Celsius, so forth and so on, and you add and you figured out how much of the substance you had to add to make it saturated. Now, the word saturated means that you've reached a point of maximum evaporation, a maximum solubility. That's what saturated means, maximum solubility at a particular temperature. Okay, so when I say solubility or saturated, it's determining determining the maximum solubility we can have for a particular temperature. So the word saturated, okay, this basically means that if I add any more solute particles to a solution that's already saturated, the extra you add is going to be undissolved on the bottom. The best example is when I get my coffee in the morning from Dunkin' Donuts. I always ask for a saturated solution, meaning I want as much sugar that can be added to this temperature of water as possible. If you add any more, it's undissolved. It's pretty hard to do at Dunkin' Donuts, but they laugh at me anyway. Now, the weird thing is, as this temperature drops, okay, sugar starts coming out in the bottom, and I have a sugar surprise at the bottom of my cooler coffee. Now, why does that work? Well, because if I have a higher temperature, let's pretend this is sugar and I'm a princess, okay, as the temperature drops, okay, you can see that the amount of sugar that was initially added is up here, and as the temperature drops, the solubility drops, the ability of the solution to keep it dissolved drops, and this red line is how much grams goes undissolved, how many grams comes out of solution. We call that precipitates out. And so I initially would have sugar perfectly dissolved if it was saturated at a certain temperature, but as my coffee cools, okay, loses heat, okay, sugar starts to appear because at lower temperatures, as I'm showing you with this curve dropping, now this isn't sugar, but we're just giving an example, at a lower temperature, the water has a lowered ability to keep that sugar dissolved. So the sugar comes out of solution and precipitates and stays in the bottom. So when I get to the bottom, I have a nice sugar surprise. Okay, so we have three basic definitions to go over. We have on the line called saturated for a particular what? Temperature, for a particular amount of grams of solute and a certain amount of water. Those are our three variables. How much water, how many grams of the solute particle, and the temperature down here. Okay? And for those 3 points, or those 3 pieces of information, we get to a certain part on this curve. If you're on the line, you're saturated. Now, any more than this, if you added over 80, you would be over the saturated line, and we would call that supersaturated. So let's say I added 90. We would call this supersaturated. And if we're below the line, meaning we could add more to the saturation point, we would call that, okay, unsaturated. So we have unsaturated below the line, okay. We have saturated on that line, and we have supersaturated. Now, supersaturated means two things. It could mean that we have an instance where the solution is holding more solute particles than possible at that temperature, and that could happen in some scenarios. Some chemicals can do this if they cool very gently, meaning if I made a saturated solution and I let it cool down from, let's say, this temperature to this temperature, and let's say like 7 degrees Celsius. Remember, temperature is my x-axis, okay? Well, the line drops, but I still have this amount dissolved if it stays motionless, okay? And if I give it a little jolt or jar, okay, the 10 grams from this point to this point, that's above the line here, will come out of solution and precipitate. And I'll show you an example of that tomorrow in class. It's called supersaturated. It can also mean that we have that many grams above the saturated point that's already in the solid phase that came out of solution. So it could be a scenario where it's still being dissolved, just waiting to be hit, okay, or struck, or come out of solution. It means it's unstable, it's going to happen, or it already has. It means how many grams above the solubility line. And it really means how much is going to precipitate out, whether it has or hasn't. Okay, that could happen in two variables like that. Now, underline means you can add more to get saturated. And those are the three very basic terms we have. Let's go to the questions. Okay. All right. Number 1, 50 grams of water saturated. Wow, a couple of things jump at me, party people. Okay, I have saturated. I have 50 grams of water. I'm at a certain temperature. This screams to me table G question because they're telling me how much water. They're telling me that I'm on the line and I'm at a certain temperature. Okay, so where am I on this curve? Let's go down there. So let's go here. Let's clean this up because I have some stuff going on. And what's the chemical? The chemical was of potassium chlorate. Oh, gotta know your chemical names. Chlorate, ClO3, -1 from table E, and K is potassium. So let's go find KClO3 at 23 degrees Celsius. Okay, so potassium chlorate, there it is, at 23 degrees Celsius. So we're going to estimate, we're right around here. And if we're off by 1 or 2 degrees, it's totally understandable. They give you that leeway. So there's my point. Okay, so they said I was saturated. So if I'm saturated, I'm on the line. Now, that's at 23 degrees. Okay, so I'm right there. So what they're saying is, in this problem, is if 50 grams of water is saturated potassium chlorate, whoa, 50 grams of water, remember our table's based on 100 grams of water. I have half the water. All right, so I'm going to have to make an adjustment to this problem. First thing I'm going to do is I'm going to find it based on 100 grams of water and make my adjustment later. So if I'm saturated at 23, I'm on the line, and I boil off all the water, that's what slowly evaporated means. I'm taking off all the water. How much salt would I recover? Kind of like one of our last Stoich labs where we took some acid that we dropped on our baking powder and we produced NaCl. And what did we do? We boiled off the water to recover the salt. Same idea. So how many grams of this salt will remain? Well, how much was in the solution to begin with if it's saturated? So we go to table G and we see that, hey, 10 grams. Remember, this number here is how many grams of this chemical we're asking about. So 10 grams of KClO3 would saturate a solution at 23, but that's based on how many grams of water? 100. So if we have half the water, 50 grams of water, then that means I will have half the solubility. So the answer is 5 grams, right? If I had 100 grams of water and the solution was saturated at 23, 10 grams of salt is in the solution. Boil the water off, you still have 10 grams. But they're saying it's saturated with 50 grams of water. It's half the water, half the solubility. So this becomes 5 grams. Okay, that's how that works. So the answer here is 5 grams of KClO3. Okay, so number 2 states, what is the smallest mass? Don't worry, I just erased this. What is the smallest mass of water required to dissolve 23 grams of NH4Cl at 40 degrees Celsius? So they're asking for how much water is needed to dissolve 23 grams of ammonium chloride at 40. So they give me 40 degrees Celsius, and they're saying I have 23 grams. How much water is necessary? What's the smallest mass of water? So let's go to our graph and see for ammonium chloride, what is the saturation point? How much, in the 100 gram of water table that I have, okay, what would it take for the table that I have based on 100 grams of water, and see if we can make any changes if necessary. So let's go to table G, and let's go to ammonium chloride. And here I am. Here's the table. And sometimes it's easy to maybe just color this again sometimes just to make it clear what line you're using. Not hard problems, but easy to get messed up with the other line. So ammonium chloride, okay, and I forgot what the temperature was. So at 40 degrees Celsius. So at 40 degrees Celsius, the saturation point is right here. Okay, it looks like to me, you know, if we give or take, this could be 40, I don't know, 47, 46, okay, making it nice and even for myself if you notice. So maybe 46 maybe, you know, as we go across here. That means 46 grams of ammonium chloride can be dissolved in, you got it, 100 grams of water. The question was, what was the minimum amount of water that can dissolve what? 23 grams at 40 degrees Celsius. Well, if 46, and it's an about number, I get it, in 100, then your guess would probably be what? Well, you got it, 50 grams, right? If you're going to have the amount at the same temperature, you must have half the water, right? Okay, so 50 grams of water, because in 100 grams of water, you can dissolve 46. So the answer above is 50, okay? So 50 grams of water will dissolve 23 grams. Not hard. 3, a saturated solution. Uh-oh, we got some keys here. So saturated, that means on the line. I got 100 grams of water, so I'm doing nothing with my problem. I'm at 40. Is heated to 50. And what's my compound? Sodium nitrate. So I have sodium nitrate. I'm on the line. I'm not doing anything to my answer because it's based on 100. My graph is based on 100. And it's heating from 40 to 50. They want to know what's the rate of increase in solubility in grams per degree. Grams per degree. Per means divide by. So let's go find it. So from 40 to 50, sodium nitrate. 40 to 50, sodium nitrate. There's my chemical. This is 10, 20, 30, 40, 50. And this is what, 60. Was it 40 to 60? I know my short term's going. 40 to 50. So that'd be 10, 20, 30, 40. Here we go, 40 to 50. Okay, so this is my 40 degrees, and this is my 50 degrees. Well, it looks to me that this number is approximately 105. This number is 115. Okay, so the difference between these two places here is 10 degrees. Or I should say 10 grams. Remember, it's grams. That's my y over 10 degrees, right? That's my x. Change of y over change of x. Essentially, I'm asking for a slope, right? So this is 40 to 50. So the change in my x is 10, and my change in my y, 105 to 115, is 10. So 10 over 10 is equal to 1 gram per degree Celsius. That's how that question is done. No problem there. 1 gram per degree Celsius. Because what do they want? They wanted I put the answer in the wrong place. 1 gram per degree Celsius in grams per degree. Okay, that was the y over x. Okay, next question. Okay, which salt has solubility values that are least affected by changes in temperature? That would have to mean that I have a solubility curve that's pretty flat. Look at that. Sodium chloride seems to have the least changes in solubility, which is probably pretty important since we use these salts in our body, these ions. And since we have fluctuations in temperature, we don't want salts to be precipitating out much. So this is why it's pretty interesting that we use this salt in our body by natural selection or something like that. Okay, so NaCl is the answer. It has the slope closest to 0. Okay, number 5 is a good question.
All right, so let's look at number 5 now. Number 5, I'm going to up the ante a little bit. Okay, let's see what kind of hints they're giving me and what hints they're not. Okay, so I've got 30 grams of KCl. Okay, that's my solute. It's dissolved in, that's a big hint right here, at 200 grams of water, and it's at 45 degrees Celsius. They want to know how many additional grams would need to make the solution saturated. So what they're saying is somehow in my curve, all right, my solubility curve for, let's say, KCl, I'm probably unsaturated. I'm below this saturation curve by some amount. And they're asking me in the problem, how many grams, from the y-axis, okay, do I need to add? Let's pretend that this is some number and it's going to go up some amount. How many grams of KCl do I have to go from this unsaturated point to this point? And that's what we're doing here. Okay, but we have to decipher some of the clues here. First of all, we have 200 grams of water. We know that our graph is based on 100 grams of water. So they gave me 30 grams of KCl in 200 grams of water. Well, isn't that really like 15 grams of KCl in 100 grams of water, right? If I double the water, I double the solubility. And the reason I go 15 grams in 100 is because, well, I have a graph below me or on the other page that's based on 100 grams of water. Okay. Remember, the variables are how much solute, how many grams of water, and how much what the thermal temperature is. So we're at 45 going to 80 for KCl. So let's go to the graph, maybe. Okay. And we're at, I believe, 45. And we want to go to 80. All right. Just make sure I'm right because my short-term memory is bad. So yeah, 45 to 80, and I'm dealing with 30 grams. All right, so I've got 30 grams of KCl and 200, which is like 15. All right, so let's do that. So it's like 15 grams of KCl at 45. So I'm right here. Now, KCl's curve is clearly up here. Okay, just making sure I know what line I'm dealing with. And of course, I'm definitely unsaturated. Now I'm going to heat this to 80. Well, the solid solutes curve goes up. And so the point is, from this point, and let's get a better color here. All right, what's the solubility to make it saturated? It looks like it's like, I don't know, 52-ish. And I'm going from here to here. So I'm going from this point to about halfway to make it soluble. So I've got 5, 10 more is 15, okay, 10 more is 25, 35, all right, and then, I don't know, 36 maybe, so maybe about 36, and they give you some leeway here. It's hard to read exactly. Now, that would be correct if I was in 100 grams of water, but the problem is in 200 grams of water, right? So 36 grams would be necessary to saturate it in 100 grams of water, but I have 200 grams of water, so I multiply by 2, and I get about 72 grams. All right, and that's what the answer is. Nothing too difficult. All right, so about 72 grams minus plus or minus 2. is needed to make it saturated in 200 grams of water. Okay, so moving on, we have number 6. At what temperature do potassium chlorate and potassium chloride have the same solubility in water? Well, okay, let's go look. Potassium chlorate is your KClO3. What the heck is that table? And the potassium chloride is KCl. So what temperature do they have the same solubility? Well, potassium chloride, let's go back to this. And let's take this away. And let's go back to a fresh chart here. So I got KCl and potassium chloride. Here's my KCl line. And my potassium chloride line is here. And they're going to cross paths right here. All right, so this is my potassium chloride solubility curve. And this is my KCl function. Okay, and they're going to cross paths and cross right around here. So I'm about 94, 95. So it's about 94. Okay. And that temperature, they have exactly the same solubility, which means they can be both have the same saturation point, which means you can add about 55 grams, right, of each of these chemicals in 100 grams of water, and it'll be completely saturated, okay, at 94, 95 degrees Celsius. So pretty simple stuff, okay, nothing really hard here. About 94, 95 degrees Celsius. Again, you get plus or minus 2 usually with these questions. Okay, number 7. At 50 degrees Celsius, 100 grams of water, and there's an important clue, we can just use the graph as is saturated on the line, potassium nitrate. How many grams will precipitate? Now, precipitate means how much solid will come out. Okay, and this is something that's kind of interesting. You have a clear solution, and what you're going to do is you're going to change the solubility or lower it in this case, and by lowering the solubility, okay, you're going to see some amount of grams above the curve, and above the curve would means that the solid would reappear out.
Is going to be about being above the line. We had other problems where we were under the curve and had to make it saturated. And this question is going to be, we're going to be above the line, which is called being supersaturated. And again, as I said, those are scenarios where you can be supersaturated and still be dissolved, but you're going to come out of the solution to make a solid and recrystallize. Okay? So in any case, our hints are we have 100 grams of water, and it's saturated, so we're on the line. And I have no temperature, and I'm at 50. So at 50 degrees Celsius, I am saturated, I'm on the line with potassium nitrate, and I'm going to cool it to 40. So my potassium nitrate, and I'm at 50 degrees Celsius, which is the 50-degree line is right here. And I'm going to cool it to 40, and I'm saturated at 50. So I'm right here on this line, which means I have 115 grams of potassium, potassium nitrate. I have sodium nitrate. So easy to make a mistake. So sorry, I'm saturated at 50, okay, and I'm right here. Okay, potassium nitrate, and I was doing sodium nitrate. So again, not hard problems, as you can see, easy to make mistakes because you're looking at the wrong curve. Okay, so that's 50, 10, 20, 30, 40, 50. Okay, now I'm saturated, which means I have 85 grams. All right, 85 grams are being dissolved completely, maximally at 50 degrees Celsius. Now, I'm going to cool it 10 degrees, and notice the solubility drops. Okay, I still have 85. I'm still right. I still have 85, but now I'm way above the line. I was saturated, but as the temperature drops, okay, the solubility drops, and now I'm this much above the line. So how much is going to precipitate out? Well, in 100 grams of water, we would have 5, 10, another 5, so about 20 grams would precipitate out and re-solidify, which means you can have a solution that's completely dissolved, cool it, and solids start to appear, kind of like my coffee at 7-Elevens with the sugar surprise. So it's in 100 grams of water, so about 20 grams. Okay, and these are classic type of table G problems. So we would say about 20 grams would precipitate, which means they would go from aqueous to a solid would appear, okay, and settle on the bottom. And it was in 100 grams of water, so we're safe based on the information we got from the graph. Okay, so number 8, how many grams of sodium chloride, NaCl, are required to saturate 500 grams of water? Now that's 5 times the amount in my graph on the next page, and it's at 100 degrees Celsius. So my friends in chemistry, there's NaCl. At 100 degrees Celsius, it's saturated, okay, at 40. So 40 grams dissolves in 100 grams of water, okay, at 40 degrees Celsius. I'm sorry, at 100 degrees Celsius, okay? So 40 dissolves in 100. Well, how much would dissolve in 500, which is 5 times the amount? 5 times 40. I mean, do I have to write a ratio? If you want, 40 to 100 is to x to 500. Clearly, we're increasing 5 times, so 5 times 4. 200 grams is our answer here, okay? The water is 5 times the amount at the same temperature. Solubility will be also, since it is the water doing the dissolving. Which compound is the least soluble, okay, in water? Now, least soluble means who's got the lowest line, okay, at 12 degrees Celsius. So let's go to the graph, okay, and let's see who's the least soluble at 12 degrees. Now, this is about 12 degrees right here. So which line is the least soluble? It looks to me at 12 degrees, the lowest line, okay, is going to be potassium chlorate. All right, doesn't really matter about the water because they'll all be the same. So at 12 degrees, potassium chlorate is the least soluble, KClO3. It's the lowest line. Number 10, at 80 degrees Celsius, 100 grams of water, so it's based on the same amount of water, is saturated, that means on the line. How many grams will precipitate? And of course, precipitate means a solid will appear, come out of the solution because the solubility is dropping. Oops. All right, I'm not sure what just happened there. Let's go back. All right, so an aqueous solution is becoming a solid. Having some minor technical difficulties here. All right, here we go. So aqueous is becoming a solid. You can read that as aqueous. So we have KCl. It's saturated, meaning on the line. 100 grams of water at 80. Solution is cooled to 45. So classic, again, above the line question. We're saturated at a certain temperature. It cools, and of course, the amount of grams that we've added to saturate stays constant, so how much are we above the line? That's how much is now supersaturated, which will come out of the solution eventually, if not immediately, as a solid. So KCl, I'm at 80. Okay, I'm cooling to 45. So KCl, let's clean this up. Okay, so I got KCl. Make sure I know what I'm doing about here. So KCl is right here. And I believe I'm at 80. Okay, so I'm saturated at 80. And we're going to go to 45. Nice point right there. So how much am I above the line? It's like 10, about 12-ish, right? We said about, we used this somewhere sometime. So there's about 12 grams of KCl. It's above this line now. So 12 grams. If it was 200 grams of water, it'd be double that. If it was 50 grams of water, it'd be half that. But I believe the question is 100 grams of water, so about 12. Okay, and I'm sure you're getting the hang of this. Okay, plus or minus 2 probably. Okay, last couple. How many grams of sodium nitrate are required to saturate 200 grams of water at 10 degrees Celsius? Okay, saturate on the line, 200 grams of water. I have twice as much water. So sodium nitrate at 10 degrees. Sodium nitrate on 10 degrees. There's my sodium nitrate. Okay, I can make sure we know what line this is. And sodium nitrate at 10 degrees is right here. Okay, and what are we doing here? I know, I keep forgetting. What am I doing here? I am seeing how many grams are required to saturate at 200 grams of water. Okay, so I know in 100 grams of water right here, it takes 80 grams of sodium nitrate to saturate 100 grams of water at 10 degrees Celsius. If it's 200 grams of water, it's twice as much, 80 for every 100, so it's 160. Okay, that was very difficult. It's like a break. Break is over. So 160 grams. And last but not least, which saturated solution of a chloride has the greatest percent by mass of solute? Now, what does that mean, greatest percent by mass? Percent by mass is part over total times 100. Now, the total is going to be the total mass of the solution. So this would be the mass of the solution, and this would be the mass of my solute. That's what a percent by mass of a solution is. It's a concentration term, okay? And that would be times 100, of course. So, who is the greatest percent by mass? Now, if you have the greatest percent by mass of a solute, okay, what that really means is who has the greatest percentage of the solute dissolved, okay, for a chloride, okay, at 60. So I'm really asking who is the most soluble salt or compound that has a chloride in it. It's the same thing, because if you are more soluble, more stuff dissolved, this curve is higher, and you're going to have a lot more mass per mass of the entire solution. As you get more soluble, you're going to be a higher percent of mass of solute to the entire solution. This number goes up, okay? And if you get more dilute, this number is a lower percentage, okay? Case in point, concentrated hydrochloric acid is 36% by mass of HCl. It's a concentration term. A dilute solution would be like a 10% by mass of HCl in a solution. Okay, so I'm looking for the most soluble chloride at 60. So let's do this. So let's go find some chlorides and let's clean this up a little bit. Okay, let's find some chlorides. All right. Okay, where's my chlorides? Well, I have, guess what? I have ammonium chloride. I have potassium chloride. I've got hydrochloric acid going down because it's a gas, less soluble at higher temperatures. I have sodium chloride. And the chlorate doesn't count. So of all my chlorides that I can see, it looks to me that at 60, the least soluble is sodium chloride, and the most soluble is ammonium chloride. All right, if I did that right, and we're looking for what has the greatest percentage, so it's going to be the highest one, so it's going to be the ammonium chloride. Okay. All right, moving on. I guess that's it. So I hope you enjoyed that, and that's it. Take care. My solution saturated, since I'm starting with an unsaturated solution. Okay, now that's if it's 100 grams. All right, 100 grams. Now was it set? I have to make sure it's 80 because yeah. So how many additional grams? So 30 is what I started with, and now I'm going from 10, 20 to 22. So 22 grams is what I would need if the solution was 100 grams, but the solution is actually 200 grams. So I would need 44 grams.